Hello, everybody. This is going to be a quick walkthrough for week 7 with ED. You're going to see Monday, Tuesday here. We're going to go over tolerances. So, this is the first week after they come back from break, focusing basically on types of tolerances, calculating tolerances, fit types, and then a tolerance activity, and then a little Lego person assembly. Just give them a kind of another refresher on how to assemble things, how to document things, how to do all that jazz. Because Friday will be the new project, flat to 3D. So real quick, because I want to have time to make sure you go over everything else. Unilateral, bilateral limit dimensions. This should actually be tolerances. Why is it only you find the mistakes while you're going through making these videos? I'll never understand that. But it gave a little definitions here, and then I break them down even more. So you'll see types of tolerances, just what a tolerance is, why they're even used, where they're used, and the applications. Then I break down unilateral, show an example of what a unilateral looks like, talk about the examples. Bilateral, show an example of what they look like, show some examples and define it. Go over limit tolerances, again, upper, lower, examples on where they would be used. And then we go over calculating tolerances, is really straightforward. When you're talking about an upper limit and a lower limit, and just finding what's called a total permissible variation. It's just basically how much overall tolerance is allowed within that design. Just shows them how to calculate that. Not even doing it within the activity, just get it on their radar and how they would be doing that if it was offered or asked. Fit types is the last part. So basically, when tolerances and just again defining it, and then we talk about a clearance fit. I show them a little picture of what a clearance fit would be. Talk about an interference fit. Talk about how they would need some. Usually, with any kind of interference fit, you're going to have interference. They usually use some kind of pressure hydraulic press system to cause that interference or to force an object into another object. Throw a little hydraulic press in there with the top 100. Use it or not, I think it's just fun. Also known as a press fit. Talk about the atmospheric temperature to slightly expand or shrink the diameter. And then a transition fit being just the combination of the two. This video walks through all of those in detail, but shows 3D models and a couple examples. I thought it was really great. And then at the end of that, Mrs. M kind of offered maybe you should segue or just give them a little preview of what could be coming here with this little pop quiz, if you want to call it that. Which type of tolerance fit do you think this company uses to assemble their products? And this is just a little hint, 2D to 3D flat pieces of wood that make these objects, as you can see behind her. Play the little video, see what they say. Hopefully, you're going to have a clearance fit in there. Talk about a tolerance activity in the Lego person. So I've created this little super straightforward tolerance, super easy. It's in Teams again, all company users tolerance activity in Onshape, and all they're going to do is make a copy of it and complete basically what's in here. So the tolerance activity drawing file. This is all I expect them to make, and I just want them to practice using these 3 different tolerances into a drawing file. And I'll show and I'll post a video basically how to do these 3. They're really easy on how to do those 3. And I did this part instead of a whole. And again, Mrs. M, after I kind of showed her this, she was, maybe we hint a little bit. It can't be just bores and, and pins and that kind of stuff. You can also use it when you're putting pieces together, such as a puzzle or such as another little piece. And again, this will give them a little bit more reference when we start talking about Thursday, Friday with the new project of a 2D to 3D or flat to 3D project where they're going to have to understand and be aware of tolerances when they're trying to build their pieces to assemble them. So as well as that, if you look at that activity, that's pretty straightforward. It shouldn't take them that long to put literally 3 dimensions in. The next thing is a Lego person activity. And all this is again, I've already made, or I found all these pieces and this little guy or girl In Teams, all company users and Lego person main. So in Onshape, that is broken up into a whole bunch of pieces and exploded already. They're going to put them back together. And again, this is after break, so it's just a little quick review on how we use assemblies, how we assemble this thing, and it should be pretty straightforward. They're going to put them together, and I didn't put in here for some reason. I didn't put, this the tolerance. I put the tolerance activity submission, but I did not put the Lego person submission, and I will do that. I apologize. But that's it for, and they can work on both of these. They should finish this tolerance activity in class, and then the Lego person, I'm assuming that they can work on Wednesday. So if I look at week 7, Wednesday, you'll see the checklist. It says to complete the tolerance activity in Onshape if they've already done that. Assemble, explode, and document the Lego person. The documentation just means bill of materials, the exploded view walkthrough, and then a drawing file with those exploded pieces with the ballooning and all that jazz that we went over before break. So I'm going to put in there, I didn't put that in there in the actual document here. I'm going to add here, the assembly needs to also have bill of materials, exploded view, and drawing file with ballooning and bill of materials. So on Thursday, Friday, you will see this new, and this is the next project, so to speak. It's going to be kind of fast, just because we only have like a few weeks, maybe a couple weeks to do this. So we're gonna go for it. Sharing a greeting just like normal. Just a quick little like reminder of what things should be due and what they should be working on, or have already done. So I put in here the design modification project. I still have some kids that maybe didn't turn in D or whatever just before break. The selfie stick assembly, the selfie stick assembly documentation and exploded view. So I put that here, I put that here, and then just a reference to the project itself. If you've not turned in these assignments, please do so. And then a flat teeth 3D project. So this is where we go over, I just refocus that we have this design process. We are using the IB design cycle. We're starting here and we're just focusing on criteria A, just like we did before. And then I, kind of refocus their agenda. Today we will start our next project. First, we will focus on criteria A. Then we start talking about what the Flat to 3D project is. So with the holidays wrapping up, get it? Wink, wink. Shipping was just on everyone's mind when it came to gifts. So in this project, you will be designing a product, any product they want, as long as it's school appropriate, obviously, that is 3D once assembled, but originally 2D. That product can can stand, or sit on a table. So your product is not required to move, but I play this little video. It's a company that basically does everything we would do if we were face-to-face, where they laser cut all their pieces out of balsa, and then they put those pieces together. So I'll go over a little bit more in detail here. Your product should be designed flat. You will then copy your design into a flat or onto a flat piece of cardboard. Next, you will cut the pieces out. And finally, you will assemble the pieces to create a 3D product. If they have a printer, obviously, they can use the printer to print out their drawing file, like you see here, basically like a little pop-out system. And I'll go into the details in a second here, and here's the document. But then they're going to put it together to create a 3D mod or three-dimensional object, using tolerances, using the type of fits, all that jazz. You should be aware and plan for tolerances and the thickness of the cardboard. So in detail, here's some examples. Basically, I couldn't take this video. This is just my Twitter from last year. These are some of the cardboard designs that the kids made last year. And you can just show this, or you can find something online, whatever you want to do. And then the specific details are here for the Flat to 3D project. And this is where I kind of go over the constraints. So again, just talking about what the design is. The constraints basically include a 3-dimensional assembled from a hand-cut cardboard pieces. The final product must be compressed of at least 4 hand-cut pieces. The cutting area can be no larger than 8.5 by 11, and I'm totally open to changing that or expanding that. Students will supply their own cardboard. Obviously, we can't be handing it out to them. And cardboard may be no thicker than a 1/4 inch, and that's just for safety. I see a lot of kids trying to do this. We used to use a 1/4 inch because it was really easy to cut through using the laser, but at the same time, now these guys are going to be using X-Acto knives or scissors or whatever they have laying around, to be honest with you. And it's going to be really hard to cut to anything thicker than a 1/4 inch, I would assume. Put the due dates here. I also put each of the guides in here for them already, and for you, if you wanted to kind of go over them. And obviously these are just the walkthroughs. I also posted the guide inside of the Thursday Friday, and then also posted the details inside of there. So if I keep going, I just literally did exactly what we did before, where I talk about what they're going to be doing, what each part of criteria A consists of, what each strand does. It was a copy and paste. So within here, just to kind of reinforce the design brief, and what they're expected to do and what questions we're going to be asking them. Maybe throw a little Jamboard. I love this idea for the last project, and Bill kind of threw this out there. I loved being able to cycle through and filter through some of their ideas to see what would work and what wouldn't work, and what would be too complex, what wouldn't be, that kind of thing. And then I break down just complete the design brief, complete criteria A guide. Before, this was really complex, so this is all they should have to do. They don't have to turn criteria A guide in, but it's a good helpful hand for them to organize their thoughts and all their research. So that'll be Monday, Tuesday, the following week, January 11th and 12th, where you guys are going to be doing your interviews. And that's pretty much it. So I will add that video, or the submission here for the Lego person, as well as the video walking through the assembly. So if you have any questions, please just reach out, guys. Thanks.